Hi everyone, welcome to School Coaching Point. Today we will discuss few important questions from the topic polynomial from class 10. Download the PDF from the link given in the description box. Subscribe and press the bell icon for more videos. So polynomial we have already learned in class 9. What type of polynomial? Linear polynomial. So linear polynomial we have already learned in class 9. So ax plus by plus c is known as the representation of linear polynomial. So ax plus by plus c is said to be a linear polynomial. Why it is a linear polynomial? Because the variable of x and y, the powers of x and y is 1. But in class 10, we will learn quadratic polynomial. So in class 10, mainly we will learn quadratic polynomial. So how can we define a quadratic polynomial? So px equals to ax square plus bx plus c, where a not equals to 0 is known as quadratic polynomial. So why it is known as quadratic? Because the highest power of the variable is 2, is known as quadratic polynomial. So if alpha and beta are two roots or zeros, if alpha and beta are two zeros or the roots of this quadratic polynomial, then sum of the two roots, alpha plus beta means sum of the roots or zeros, sum of the zeros is equals to minus b by a. So minus b means the coefficient of x. So b means coefficient of x, and a means coefficient of x square, and product of the roots alpha into beta means the product of the two roots. So product of the roots is equals to c by a. So product of the two roots c by a. C means constant term. Constant term. A means coefficient of x square. So constant term divided by coefficient of x square is the product of the two roots. So sum of the two roots minus b by a and product of the two roots c by a. So let's move to the next important point, representation of a quadratic polynomial, when sum of the roots and product of the roots are given. So representation of a quadratic polynomial when sum of the roots and product of the roots are given. So if alpha and beta are the two roots or zeros of the polynomial, if alpha and beta are the two roots or zeros of the quadratic polynomial, then the quadratic polynomial can be expressed as k bracket x square minus alpha plus beta into x plus alpha into beta. So k bracket x square minus sum of the two roots, alpha plus beta means sum of zeros or sum of the roots into x plus product of zeros. So let's move to an important question. If alpha and beta are the zeros of the quadratic polynomial, satisfies the relation alpha square plus beta square plus alpha beta equals to 21/4, find the value of k. So it is a very important question. So px, suppose the px is the polynomial 2x square plus 5x plus k is the given polynomial. So alpha and beta are the zeros of this given polynomial. Therefore alpha plus beta equals to minus b by a. So in the given polynomial, a equals to 2, b equals to 5 and c equals to k. So therefore alpha plus beta means minus b by a, so it's minus 5 by 2. And product of the two roots alpha into beta is equals to c by a. C means k, a means 2. So alpha into beta equals to k by 2. Now alpha plus beta whole square is equals to alpha square plus beta square plus 2 alpha beta, a plus b whole square form. Implies alpha plus beta whole square, alpha square plus beta square plus 2 alpha beta, you can write as alpha beta plus alpha beta. So 2 alpha beta means alpha beta plus alpha beta. Now alpha square plus beta square plus alpha beta means 21/4. So given alpha square plus beta square plus alpha beta is equals to 21/4. So therefore alpha plus beta whole square is equals to, so replacing the value 21/4 plus alpha beta implies alpha plus beta means minus b by a means minus 5 by 2 whole square equals to 21/4 plus alpha beta means k by 2. So it's 25/4 equals to 21/4 plus k by 2. So 21/4 transposing to the left hand side, 25/4 minus 21/4 is equals to k by 2. So 4 is the LCM, 25 minus 21 equals to k by 2. So 25 minus 21 is 4. 4/4 equals to k by 2. 4 by 4 means 1s, so k by 2 equals to 1, implies k equals to 2. So it's very important question. So let's move to the another question. If alpha and beta are the zeros of the quadratic polynomial ax square plus bx plus c, then find alpha square plus beta square, Roman 2 alpha by beta plus beta by alpha, Roman 3 alpha cube plus beta cube. So this is a very important question. So in this case, polynomial is given. So fx equals to ax square plus bx plus c. This is the given quadratic polynomial whose roots are alpha and beta. Therefore, alpha plus beta should be minus b by a and alpha beta equals to c by a. Sum of the two roots and product of the two roots. Now, we have to find out alpha square plus beta square. So alpha plus beta whole square means alpha square plus beta square plus 2 alpha beta a plus b whole square form. So alpha plus beta means minus b by a whole square plus alpha square plus beta square plus alpha beta means c by a. So 2 into c by a. Minus b by a whole square means b square by a square is equals to alpha square plus beta square plus twice c by a. So b square by a square twice c by a transposing to the left, twice c by a is equals to alpha square plus beta square. So in the denominator, power of a is 2, highest power is 2, so is b square by a square. So here a square, here a, so multiplying a in the numerator as well as in the denominator. So b square by a square minus twice ac by a square is equals to alpha square plus beta square. So in the denominator a square and in the numerator b square minus twice ac equals to alpha square plus beta square. So alpha plus beta and alpha beta, after finding the value of alpha plus beta and alpha beta, expanding alpha plus beta whole square, putting the values of alpha plus beta and alpha beta. So after simplifying, we get b square by a square minus twice ac by a square equals to alpha plus beta square. So after simplification, b square minus twice ac by a square equals to alpha square plus beta square. So let's move to the Roman number 2, alpha by beta plus beta by alpha. So beta and alpha are in the denominator, so LCM should be alpha into beta. So alpha into alpha, alpha square, beta into beta, beta square. So alpha beta, value of alpha beta we know c by a. Alpha square plus beta square how much? B square minus twice ac by a square. So b square minus twice ac by a square. And c by a, it becomes reciprocal a by c. So b square minus twice ac by a square. So you can cancel 1a. So b square minus twice ac by a into 1 by c. So b square minus twice ac by ac. So alpha plus beta equals to minus b by a, alpha beta equals to c by a, and alpha square plus beta square equals to b square minus twice ac by a square. Now Roman number 3, to find alpha cube plus beta cube. Now alpha cube plus beta cube equals to alpha plus beta into alpha square minus alpha beta plus beta square. So this is the identity from class 9. So alpha plus beta bracket alpha square plus beta square minus alpha beta. So alpha plus beta means minus b by a. Alpha square plus beta square means b square minus twice ac by a square minus alpha beta means c by a. So is equals to minus b by a, b square minus twice ac by a square, and a square power highest power is 2, so a into a, c into a, minus b by a, b square minus twice ac by a square minus ac by a square, minus b by a bracket a square is in the denominator, so b square minus twice ac by ac minus b by a, so b square minus twice ac minus ac is thrice ac, so a into a square, it becomes a cube minus b bracket b square minus 3ac so minus b into b square minus b cube minus b into minus 3ac plus 3abc by a cube, so 3abc minus b cube by a cube. Move to the next question. If alpha and beta are the zeros of 2x square minus 5x plus 7, find a polynomial whose zeros are twice alpha plus 3 beta and 3 alpha plus 2 beta. So this is a important question. So alpha and beta are the zeros of the polynomial. So here the polynomial is given. So px equals to 2x square minus 5x plus 7. So alpha and beta are the two zeros. So alpha plus beta is equals to minus b by a. So minus b by a means, so in the given polynomial a equals to 2, b equals to minus 5 and c equals to 7. So alpha plus beta means minus b by a. It means minus bracket minus 5 by 2. So minus minus plus 5 by 2. So alpha plus beta equals to 5 by 2. Alpha beta equals to c by a. So c is 7 and a is 2. So 7 by 2. Now we need to find out a polynomial whose zeros are 2 alpha plus 3 beta and 3 alpha plus 2 beta. So now 2 alpha plus 3 beta and 3 alpha plus 2 beta are zeros of the new polynomial. That means find out a polynomial. So we consider as the new polynomial. So these are the zeros of the new polynomial. So first of all we should find out the sum of the zeros. So sum of zeros equals to twice alpha plus 3 beta plus 3 alpha plus 2 beta, because we know that for finding the polynomial we should find out the sum of zeros and product of zeros. So 2 alpha plus 3 beta plus 3 alpha plus 2 beta. So it's 5 alpha plus 5 beta. So taking 5 common, alpha plus beta equals to, alpha plus beta means 5 by 2. So 5 into 5 by 2 is equals to 25 by 2. So this is the sum of the zeros of the new polynomial. Because we know that for finding a polynomial we should find out the sum of zeros and product of zeros. Now product of the zeros, now product of the zeros, 2 alpha plus 3 beta into 3 alpha plus 2 beta is equals to 2 alpha into 3 alpha 6 alpha square, 2 alpha into 2 beta 4 alpha beta, 3 alpha into 3 beta 9 alpha beta, 3 beta into 2 beta is 6 beta square. So 6 alpha square 6 beta square, 6 you can take common, 6 alpha square plus beta square plus 13 alpha beta. So product of the roots is equals to 6 alpha plus beta square plus 13 alpha beta. Now alpha plus beta whole square, we should find our value of alpha square plus beta square. So alpha plus beta whole square equals to alpha square plus beta square plus 2 alpha beta. So transposing 2 alpha beta to the left, so alpha plus beta whole square minus 2 alpha beta equals to alpha square plus beta square. Alpha plus beta means 5 by 2. So it's 5 by 2 whole square minus 2 into alpha plus beta means 7 by 2. So 2 into 7 by 2 is equals to alpha square plus beta square. So 5 by 2 whole square means 25 by 4 minus 14 by 2 is equals to alpha square plus beta square. So 25 by 4 minus 14 by 2, LCM is 4. So 25 minus 28, 14 to the 28 is equals to alpha square plus beta square. So in the previous steps we get 25 minus 28 by 4 equals to alpha square plus beta square. So it's minus 3 by 4 equals to alpha square plus beta square. Product of the two roots. Now product of the two roots. So in the previous step we got product of the two roots in the previous steps. Six bracket alpha square plus beta square plus 13 alpha beta. So putting the values, 6 into alpha square plus beta square is minus 3 by 4. So minus 3 by 4 plus 13. What is the value of alpha beta? Is 7 by 2. Because we know the value alpha beta, product of the two roots is 7 by 2. So 6 into 3 minus 18 by 4 plus 13 into 7, 91 by 2. So 4 and 18 you can cancel, minus 9 by 2 plus 91 by 2. Taking the LCM to 91 minus 9 is equals to 82. So is equals to 41. So product of the two zeros how much we get is 41. So sum of the two roots or sum of the two zeros is equals to sum of the two zero or sum of the two roots of the new polynomial. We get sum of the two zeros of the new polynomial we get in the previous steps. So what was the sum? 25 by 2. And product of the two roots, how much we got? 41. Therefore the required polynomial, therefore the required new polynomial k bracket x square minus sum of the zeros into x plus product of the zeros. So k bracket x square minus sum of the zeros, how much we got? It's 25 by 2. It's 25 by 2. X plus product of the zeros, how much? 41. So k bracket x square minus 25 by 2x plus 41 is the polynomial.